Jai Hind, myself Anuj Dwivedi, Assistant Professor CSE Department, AKGEC Gaziabad. Today we will discuss one of the major operation in array, that is searching. So we will learn how the searching approaches work and how we can perform this operation in a given list. So let's first try to learn what do you mean by searching. So searching is a process. Searching is a process of finding a particular value or finding a particular uh, location where the particular item is exist. Preliminary conditioning is that the list is already exists and we want to search a particular element, or we want to find out the particular element location in a given list. So how we can perform this operation in a given list. So if we talk about the searching, so if we continue trying to find out our desired element, and then if desired element is found in the given list, then we call the searching is successful, otherwise we call the searching is unsuccessful. If we scan whole of the list and not able to find particular element. So here there are two approaches to find out an element in a given array. First approach is linear search and the second approach is binary search. So we will discuss both the approaches. So both the approaches are based on comparison based, right? And first we will discuss about the linear search, how we will find our desired element by the use of some technology that is called linear search. So this linear search process does the very simple thing, that is it start traversing the array from the beginning and it will continue till the time we will not find our element. As and when we find out our element, we stop searching, right? It may continue till the whole the arrays exhaust. If whole the arrays exhaust and we are not able to find out our desired element, this situation is called unsuccessful search. So first we try to learn what is the meaning of linear search, right? So simple process, we sequentially go one by one elements and compare our desired element with the array elements, and if the element as and when element is matched with the list element, we declare that element is found, right? So how you will work with the linear search, the step by step theoretical algorithm is like that. So first read your desired, you have to have knowledge about the what element you want to find out in the given list. Then compare the your key element with the first element of the array, right? If both the element are matched, then you may say element is found and you will terminate the search procedure, right? If both the elements are not matched, then continue searching for the further elements and you may continue till the last element of the array, right? So repeat step 3 and 4. If element is matched, terminate the process. If element is not matched, then continue till the last element of the array. This process will continue, right? If the last element is, if you reach till the last element and element is still not found, then obviously you have to terminate the function with the unsuccessful result. So this is the procedure of the simple and sequential procedure by which you can find out any element in a given list. That's called linear search. Now if we talk about the technical terminology, or technically how we will define the procedure in the C language, then this is the whole procedure. We assume that we have a list, right? We have a already list named array A and have some element, right? So we have here, we are trying to understand this approach with the help of this function. So here we pass an array in the function and size of the array and key element, what is our desired element that we want to find out in a given list. So what we are going to do now, we will simply use a for loop for the traversal. Just like traversal purpose, we run a loop for beginning up to the last element of the array. So keep attention how we are designing a loop. We know the array elements, array indexing start from 0. So we start loop here from I equal to 0, I less than equal to size, and I plus plus. So here we planned how to scan whole array, right? And we are start comparing key element. We already know what element we want to find out in this particular given array. So if key compared with first element, A0 means first element of the array. So firstly we will compare the desired element with the first element. If item is found, then we found item found at the location this, and we stop or terminate the function with the help of return keyword. Simply when return encountered, if condition is true, return will encounter, and you know each and every function can return only one and one value. So as and when return will encountered, function will terminate automatically, right? So this process will continue, for loop will continue, right? Now when suppose there are two possibilities. One, when particular element is found, then return will encounter and function will terminate. Otherwise whole for loop will continue till the size of the array. So suppose we are coming out second possibility, when we reach the condition where we compare I equal to size, meaning we compare whole element, whole array, we scan whole array, and if I equal to size, what does it mean? It means that item does not exist in the list, that means search is unsuccessful. So you can see this is very simple searching methodology. We just start from the beginning and continue till the end position of the array. There is two possibility, either there will be element will be there, either will be element will be not there. So this kind of searching methodology is known as linear search, right? So you know, whenever you learn a particular algorithm or whatever algorithm you are learned, then analysis is the must part of any algorithm. So what is the fruitful result, what is the outcomes of the algorithm in terms of complexity, you may visualize with the help of analysis procedure whatever we have. So this algorithm, this linear search algorithm, perform best case. Best case means if our desired element found in the first position, found in the very first position, then there will be order of 1 complexity, because if you using only one comparison in finding out the desired element, so if you use only one comparison you find out your result. So this is the best case of this searching technology, right? And suppose second case, if whole for loop you traverse whole the array and finally you come to the result that element is not in the list, then how many comparison you have used? Total n plus 1 comparison. So whole n comparison you uses, and after and finally you declare there is no element whatever you want to find out in this element. So this is the worst case where you scan whole the array and you can't able to find that particular element because it is not existing in the given list. So this is the worst case of linear search, that is order of n. So keep remember, best case of the linear search is order of 1 and worst case of the linear search is order of n. So this is the whole theory of linear search. Now we implement this linear search algorithm and use the whatever function we have discussed earlier that is used with the in this program, and we implement in a given list that the size is 50. So this is the program that you can visualize by in any compiler, right? So now we will discuss another very important methodology for searching, that is binary search, right? So binary search is another procedure where you can find out the element in a given list with the similar way, right? So basic concept of problem statement is same, right? But approach is different from binary search, right? So when binary search is also comparison based searching algorithm, but here first requirement of applying binary search is that the array must be sorted list. So if your array is random, then you can't able to apply binary search. First you have to sort that particular element, then you can perform binary search in a given list, right? So main, as we see in previous algorithm, that best case was order of 1 and worst case was order of n. In binary search we will prove that the worst case of the searching is order of log n. Worst case is log n and best case is obviously order of 1. So here we will discuss theoretical algorithm for binary search, how binary search will work, and try to conclude how it is different from linear search. So in step 1, read the search element what you want to search. Then first we find out the middle element. We are not going sequentially, keep attention. We first calculate the middle element of the sorted elements. We see later how we will calculate the middle element. Then compare the search element with the middle element, right? So in the sorted list, then if both are matched, if both the element matched, we display the given element is found and we terminate the procedure, right? If both elements are not matched, then check whether search element is smaller or larger than middle element, right? We have choices here. Either we have select left side array, either we have to select right side array. So here we have two choices, right? Either we go for left side, either we go for right side, right? So if the search element is larger than the middle element, we repeat step 2, 3, 4 and 5, right? Repeat the same process until we find out the element in the list, until the sublist contain only one element, right? So what we are doing? First we are calculating the middle element of the array. We calculating our desired key element with the middle element, right? If middle element and the key element are the same, then we declare that this is element is the found and the search is successful, right? If the element is smaller than the middle element that we want to find out, then obviously we pick left side array. If the element is larger than the middle element, then obviously we will move right side of the middle element, right? So in one situation we have to calculate end element of the array, right? And in another situation we have to recalculate beginning of the array. So this process will continue until we have not come to the array whose size is only one element. So let's try to learn the whole procedure with the help of this example. Here we have a array of 7 elements, right? So you know indexing will be 0 to 6. So we plan our problem that suppose we are trying to find out 15, right? So we have to fix indexes as per the C norms. So beginning index is 0 and end index is 6. So how you will calculate the mid of the array? Mid of the array will be beginning plus end divided by 2, that is 3, right? So just focus on A3. Value on the A3 is 20 and you want to find out 15, right? So you may able to conclude that our desired key value is less than the mid value, right? So obviously we will go left side of the middle element, right? And we will focus on the left side array, that is 3, 10, 15. So now beginning of that array is fixed and we have to recalculate end of the array, right? Then again we calculate the mid of the array, 0 plus 2 divided by 2, that is 1, right? If we calculate from the mid, then we find out our desired key element is greater than 10, that is mid element greater than 10. So obviously we have to pick right side of the array, right? When we going to pick right side of the array, then end is fixed, we recalculate the beginning of the array. So we calculate beginning of the array, then we recalculate the mid, then we find out 2 plus 2 divided by 2, that is 2. So we come to the conclusion that now we reach the position where only one size of arrays exists, right? In that situation, if element is matched, then we say element is found out, otherwise we say element is not found out. But keep remember, in this whole process we are dividing array again and again. Suppose this is an array, what we are doing? We are splitting this array in two parts, right? In two parts. Mid element, here is mid and here is left of mid, here is right of mid. Now you may see in this is the binary tree, and suppose you go left side, then again whole procedure we repeated, then again we calculate mid and left right. This will continue, right? In whole procedure we may go for left side of array, we may go for right side of array, this will continue, right? So in this procedure what we are doing, we are doing this approach, right? That's called divide and conquer approach, right? And if we visualize our whole algorithm, so we are working with a binary tree, right? Binary tree. This will continue and finally you will get result, right? So we are not going to give you technical proof here, but keep remember, height of the binary tree is log n. Log n. And one thing keep remember, when you using log in terms of binary tree, keep remember base of the log will always be 2. In your previous knowledge database, base 10 exists in your knowledge database as you have previous studied in the mathematics, but here at the basis of binary search you have to keep remember always that in case of binary search you have remember that base of the log is 2, right? So how many comparison you can use here? In first level, when you comparing your desired element with the mid, only one comparison. In second label, either you go for left side, either you go towards right side, and obviously you will use only one comparison. You will use only one comparison in each label, right? Total labels in this binary tree is log n, and in each label you are using only one comparison. So how many total comparison you can use in whole searching procedure? Only log n. That's why we saying that worst case of the binary search is log n. That's the reason. Total label in the binary search is log n. So how many comparison? Maximum log n comparison you can perform. After then you will get the result. So this is the whole procedure of binary search. This is the technological difference between linear search and binary search, right? So this is the procedure, how the theoretical algorithm will perform in the C language, right? We will calculate the mid element, right? If we go left side of the array, we calculate end of the array. If we start from right side of the mid, then we start beginning, we will calculate mid of the array, and process will continue. And up to what long you can continue, means up to what long your procedure will go, repeat and repeat and repeat, that will ensure with the condition, that is if big less greater than end. That means up to label where only one elements will remain in the array, right? When beginning is greater than end, that means array elements has been exhausted and there is no more possibility to find out element in the given array, right? So best case is simple. Best case is that when you start searching up the element, in very first hit you find out match your mid and with key value, then there is only one comparison. So we define one comparison as a order of 1, right? If there is a, let's say, elements found at the last and element not found at all, in that case you can perform maximum log n comparison. So we will say the complexity of binary search in worst case, that is log n. Let's say we try to explain working of binary search with the help of an example. Suppose you have an array and that array have 2 to the power 20 elements, 2 to the power 20 elements, and you have to find out the kth element by use of linear search. Then in worst case, how many comparison you need to perform? 2 to the power 20 comparison you have to perform, because we start traversing. This is sequential search. You will compare each and every elements with your desired element. So 2 to the power 20 comparison you have to perform to find out your element, to come to the decision whether the element is exist or not exist. But let's see how this search algorithm perform same problem statement. If we use binary search for find out the k element in the array that size is 2 to the power 20, then if we put 2 to the power 20 with the log n, in worst case scenario, if we put 2 to the power 20 with log n, then you know worst case complexity was order of log n, where base of the log was 2. So when you put 2 to the power 20, you may see the total number of comparison will be maximum 20. You find out the desired result in the worst case scenario, that will consume only 20 comparison. So this is the power of binary search. You may see huge difference. In linear search, you are going to use 2 to the power 20 comparisons to find out a particular element, and in the binary search you are needed only 20 comparison to find out desired element. So this is the whole program where we incorporated the function or algorithm in the function. So this is the whole program that will work for generalization. You have to implement in particular compiler for the see the result of this program. So you may input sorted array, you have to input sorted array, right? Then this program work perfectly. If you not input a sorted array, then this program will not perform as you have learned here. So here same problem statement is same. Here we using recursive approach, right? In previous approach that was based on divide and conquer, we are using iterative approach. Here is also divide and conquer approach, and difference is that we are using recursion. We performing repetition with the help of recursion, but keep remember there is no difference between iterative binary search and recursive binary search. This procedure will exist, but in the terms of complexity it will not going to improve any complexity, not going to complex any situation. So better to use iterative recursive iterative search, that is better for general use. So these are the references for you can use these references for further learning. So thank you.